All right, welcome to the Thursday Allen Mentoring stream. I believe our official lesson count is number 7. What I will be going over today is SAT Blue Book, the official College Board Blue Book, test number 3. So this is practice test 3. If you want to follow along, you can check out the description, and in there you will find a link to the College Board website where they have kindly provided us with all of the practice tests in the Blue Book for free. You have all the PDFs of the tests, you have all the answers, so that was very nice of them to do so. And I will be going through every single question of every single test, the math questions that is, until we get to the end, or until you get bored, or until I get bored, or until one of those things happen. So today we are covering actually a half section. We are covering the short answer calculator half section. So this is section 4 in practice test number 3, and we'll be starting at question number 31. So if you want to see questions 1 through 30, go into the video archive and click on the lesson number 6, which is the one right before this one. Okay, and that has all the answers from 1 to 30. And as always, you can write in the comments if you're watching, or write in the chat if you're watching this live, or if you're watching this after the fact, you can write in the comments for any questions or clarifications if I went too fast, too slow, and I'm pretty good with responding to comments. So if enough people ask the same question, I might do a separate video just addressing that topic. Okay? And then I guess last thing before we begin, just a reminder that I will be doing surprise subscriber videos or streams where I will be going on at random times, not at normally scheduled times, and whoever is a subscriber will get an email saying, oh, Allen Mentoring is on, boom. And you can probably ask me questions that otherwise you might not have time for, or that I might not answer because I'm trying to get through the SATs. In those sessions, you can pretty much ask any math question that's bothering you, and if I know the answer, I will go through it. All right, so hit the subscriber button if you want to attend one of those sessions, and let's get started. So let's get to number 31. Tickets for a school talent show cost $2 for students and $3 for adults. If Chris spends at least $12, but no more than $14 on X student tickets and 1 adult ticket, what is one possible value of X? Okay, so we can do this, a few ways as always. We could either do it algebraically, or we could choose our own numbers. Just to toss it up, I'll choose a number, right? If he spends between $11 but not more than $14, let's say he spends 12. All right, we'll just say that for fun. And he has at least 1 ticket, 1 adult ticket, and some number of student tickets. So if, let's say, there are 2 adult tickets, right, times $3 each, then that means that he spent $6 on adult tickets. And so we'll subtract $6 from here. And so there are $6 left for student tickets. And since student tickets cost $2 each, we obviously know that there are 3 students and 2 adults in this example. And I could have picked any number. I could have picked 11, 12, 13, 14. And so I picked 12, and I found out that there are 2 adults and 3 students. And so X represents student tickets, so I could put 3 as an answer to X. All right, and there are several different answers that you might get depending on what number you chose. All right, 32. Ages of the first 12 United States presidents at the beginning of their terms. Okay. The table above lists the ages of the first 12 U.S. presidents when they began their terms in office. According to the table, what was the mean age in years of those presidents at the beginning of their terms? All right, so it's pretty easy. We are just trying to find the mean of these 12 numbers. And the way that you find out a mean is you add up all the numbers and you divide it by how many numbers you have. So in our case, we have 12 different numbers. So we'll have to add up all of these ages and divide by 12. So let me get to my handy dandy calculator, which you can use in the calculator portion. And let's see, hopefully I don't mess up. And this is one of those questions where you really want to just focus hard, right? You don't want to go too fast because this is a super easy problem. And the only way that you'll probably get it wrong is if you go too fast. All right. Or if you, I don't know, mess up your calculator thumbs. So let's try to be careful here. Let me start again. So 57 plus 62 plus 58 plus 58 plus 59 plus 58 again, plus 62. Oh God, see I almost messed up? See, wait. Okay, I'm gonna divide that by 12. And so I get 58 here. And what you wanna do is you wanna just quickly look over and see, does this make sense? Like if you had something around 85, you'd be like, wait a minute, I probably missed a number because that seems way too high. If you had like 43. So 58.58 seems to be accurate based on my numbers here. Round your answer to the nearest tenth. Okay, so the nearest tenth. So I have 58.53. Oh no, sorry, 0.58. So I'm rounding it to the nearest tenth. Since 8 is right next door to it, that means I have to round up. So 58.6 is our answer there. Excellent. Okay, if the above expression is written in the form ax squared plus bx plus c, also known as standard form, where a, b, and c are constants, what is the value of b? Okay, so basically we just have to combine these expressions into one single trinomial, and to do that we have to add like terms. So the first thing we want to do is get rid of the parentheses. Okay, so let's see how we would do that. In the beginning, there's nothing in front of these parentheses, so we can just get rid of those right off the bat. Okay, so we can get rid of these initial parentheses, plus 5x minus 2. Now, I want you to be very careful here. If you ever have a negative number in front of a parentheses, do not forget to distribute that negative as well. Do not just distribute the 2, okay? You have to distribute negative 2 to each of these. So we're going to multiply negative 2 by each of the terms inside of these parentheses. Okay, so negative 2 times positive x squared is negative 2x squared. Negative 2 times negative 2x is positive 4x. And then negative 2 times negative 1 is positive 2. So if you've gotten this far, you're in pretty solid shape. An easy way to mess this up is to forget that you're distributing a negative number, and you would just distribute positive 2, or maybe just change this front one to negative. Nope, you have to distribute negative to every single term inside the parentheses. So let us combine like terms now. So the like terms are going to be the x squared, the x and the x, and then the constants and the constants here. Okay, so negative 3x squared minus 2x squared. So negative 3 minus 2 is negative 5x squared. Plus 5 plus 4 is plus 9x. And negative 2 plus 2 is 0. So we actually don't even have to write that. And so what do they ask us? What is the value of b? Well, if I just put plus 0 here, we see clearly that a is negative 5, b is 9, and c is 0. So we want to find out what b is. So b is 9. Bam. All right. In a circle with center O, central angle AOB has a measure of 5 pi over 4 radians. The area of the sector formed by central angle AOB is what fraction of the entire area of the circle? So let's see if I have a circle drawing tool here. Okay, nice. So basically, let's say we have some sort of, right, this is O. And so we have some sort of angle, and I don't know if it's acute or obtuse. I don't really know that yet. Okay, but I know that this is A, this is B, right? So we know that this angle right here is 5 pi over 4. And so our goal is to find out what fraction of the entire circle is just this sector. Okay? So how are we going to find that out? Well, a really cool way to do this is if we find out what the measure of this angle is, right? So let's say this angle is 120 degrees, for example, right? If this is 120 degrees, then we know that this arc is also going to be 120 degrees because the central angle is equal to the arc length. Okay, so if this angle is 120 degrees, for example, this arc would also be 120 degrees. And if this arc is 120 degrees, we know that the entire circle has 360 degrees. So 120 out of 360 would be 1/3. Okay, and so we would know, aha, if this arc is 1/3 of the circle, this sector is also 1/3 of the area. So that's how we would do it if it was 120 degrees. We'll do a similar thing, except we have to find out how many degrees this angle is. So how do we convert 5 pi over 4 radians into degrees? And the way that you do that is you remember that pi is equal to 180 degrees. Whenever you're converting radians to degrees, do not forget that pi is equal to 180 degrees in your calculations. And so if that's the case, you would do 5 times 180 divided by 4. Okay, and so what is that? So 5 times 180 is 900 divided by 4. Okay, 225. So we know that that central angle is 225 degrees. Okay, well, what is the fraction, right? If this central angle is 225, then this arc is also 225. So what fraction is 225 out of 360? So in this case, you just kind of have to find out your, you have to simplify. So what factor does 225 and 360 share? Well, I know that we can divide both of them by 15, okay? And so 225 divided by 15 is 15, and 360 divided by 15 is 24. So that would reduce to 15 over 24. And now, what do they both share? Well, we can divide them each by 3. And so now our simplified fraction is 5/8. So this arc is 5/8 of the circumference, and this sector is also 5/8 of the entire area. All right. Excellent. All right, 35. An online store receives customer satisfaction ratings between 0 and 100 inclusive. In the first 10 ratings the store received, the average of the rating was 75. What is the least value the store can receive for the 11th rating and still be able to have an average of at least 85 for the first 20 ratings? This is actually an interesting problem. I like this. So we know that the first 10 ratings have an average of 75. Okay, so if you look at the first 10 ratings, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and let me put 20 here. 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? So we know that the first 10 have an average of 75. It actually doesn't really matter what each of these are. Like this could be 70 and this could be 80 and it would still average 75. We don't actually have to know what they are. We just know that the average is 75. The average is 75. Okay, and that tells me that the total of the first 10 ratings, the total is equal to 750. Okay, the total is 750 for the first 10 ratings. Now, if we want the first 20 ratings to have an average of 85, we can do the same thing, right? We can imagine that all of these are 85, and we could find out what is the total that you would want all of your 20 ratings to, what would be the total of your 20 ratings, right? So if it's 85, we can multiply 85 times 20. 85 times 20 is 1,700. So So we know that all 20 have to add up to be 1700, right? If the average is 85. So maybe we should subtract 750 to find out what is going to be the total of these next 10 ratings, right? What is the total of the next 10 ratings? Because once we know that, we could see, aha, what is the minimum of the first, right? What is the minimum of the first rating so that we could still get that total? So if we subtract 1750 or 1700 minus 750, we get 950. So we know that the total of these has to be 950. So the big question is, what could the first rating be, right? What is the least value the store can receive for its 11th rating so that the total of these next 9 could be 950, right? And we know that it's only between 0 and 100. So let's say, for example, that this first rating got a 0, right? If the first rating got a 0, that means that the other 9 would have an average of 105. Do you see that, right? If it would have an average of 105. And you're like, wait a minute, that's impossible, right? It can't have 105, right? What would be, let's say if it was 10, for example, right? If this first rating was 10, then we would subtract 10 from 940. We would do 940 divided by 9. We would see, wait, 104, that still doesn't work, right? It needs to be the highest they could possibly be is 100 each, right? So if those other 9 are 100 each, that means that this first rating has a minimum of 50, right? If we assume that every single one of these 9 is 100, right? They got the best rating possible, then that would be 950 minus 900. And so the only thing that this last one could be would be 50, right? That would be the minimum value. So I hope you followed along. And this strategy is actually done for other problems that involve averages. So for example, you have problems where it says, oh, you have 18 kids in the class who score an average of 65. What is the least value that the 9th student could make so that the average would increase by 1 point? And you do something similar where you're trying to find out the total points and then subtract from the total that you need. Okay. Oops, I kind of infringed on number 36's space here. Okay. All right, and if you have any questions, hit me up in the chat. I'm always available to answer any of your concerns or comments, even if it's about my teaching speed or unclear language or illegibility of handwriting. I'm cool with that. All right, got pretty thick skin, so just lay it on me. As long as, you know, being respectful. Okay, 36. In the xy plane, if a point with coordinates a, b lies in the solution set of the system of inequalities above, what is the maximum possible value of b? Aha. So these are basically two inequalities, right? They'll look something like, I don't know, just randomly if I was to draw them. And then maybe one has something like this, another one has something like that. Okay, so the solution would be somewhere in this area right here, right, where they overlap. And so there's going to be some sort of point, right? Let's say that point is right here, and that point is AB, and they're saying what is the maximum possible value of B? So what's interesting is if you want to find out all the possible values of these two lines, right, we could set them equal to each other. Just like you would do any other system of equations, this is a system of inequalities. So what you could do is you could set these two to be equal to each other, right? So we could say that that 5x is equal to negative 15x plus 3,000. Okay, and if we solve that, we would add 20x to both sides. Okay, we want to do the opposite to both sides. Wait, why am I adding 20x? Sorry, plus 15x. I got ahead of myself here. I added that because this is equal to 20x. Duh. 20x is equal to 3,000. Okay, divide this by 20. Divide this by 20. And now x is equal to, and if I get rid of these zeros, 300 divided by 2 is 150. Okay, 150. So now if we look here, we would see that we can plug in x for either of these two equations, either of them. Let's say I plug it in for the second one. Y is less than or equal to 5 times 150. And then y is less than or equal to 750. Okay, so if I didn't go too fast and all my numbers are correct, because I didn't use the calculator. All right, if all my numbers are correct, then that means that y has to be less than or equal to 750. And if you see here that AB is basically like saying XY, right? They just picked another 2 letters just to mess with you, but really any point on here can also be referred to as XY, right? This is on an XY plane. So basically it's saying, what is the maximum possible value of B? Well, we know that B is basically the same thing as Y, right? It's the Y value. And Y has to be less than or equal to 750. So the maximum possible value of B, aka Y, is 750. Boom. I hope that is the right answer. I actually did not do these in advance. So if I'm making like some crazy mistake and I'm totally blind to it, just let me know in the comments and I will thank you. All right, last 2 problems in this section 4 of practice test number 3. Shoppers enter a store at an average rate of R shoppers per minute, and each stays in the store for an average time of T minutes. The average number of shoppers in the store, N, at any one time is given by the formula N is equal to RT. Okay, that makes sense. So this is shoppers per minute. This is number of minutes. So if you multiply those together, then you get number of shoppers. And that is known as Little's Law. Gotcha. The owner of a good deal store estimates that during business hours, an average of 3 shoppers per minute enter the store, and each of them stay an average of 15 minutes. The store owner uses Little's Law to estimate that there are 45 shoppers in the store at any time. Okay, I see how he uses that. I don't know if this is going to be relevant for our problems, but we'll see. So Little's Law can be applied to any part of the store, such as a particular department or checkout lines. Okay, the store owner determines that during business hours, approximately 84 shoppers per hour make a purchase, and each of these shoppers spend an average of 5 minutes. Oh, I see what they're trying to do here. 84 shoppers per hour, huh? You see that? It's not per minute. Got to be very careful. 3 shoppers per minute, 84 shoppers per hour. You see, they should have actually underlined this if they're going to do this. Like I see up here, they underlined per hour. I don't know why they didn't do it in this number 37. That's kind of mean. All right, so be very careful when you're dealing with rate problems. Make sure it's the same exact rate. Spend an average of 5 minutes in the checkout line. At any time during business hours, how many shoppers on average are waiting? Okay, so if it's 84 shoppers per hour, all we have to do is find out how many per minute and then multiply it by 5 minutes, right? Because that's how we use Little's Law. So how do we do that? So we have 84 shoppers per hour, right? So we can write this, and if you actually saw the last video, we went over how to do rate conversions and unit conversions. So this is 84 shoppers per hour, per 1 hour, right? And what we want to do is we want to get it into shoppers per minute. So we want to convert hours to minutes. And the way that we would do that is we say, aha, we want to cancel out our units diagonally, right? So if we have hours down here, we say, okay, well, we have 1 hour in 60 minutes. Okay, and by writing it in 1 hour over 60 minutes, not 60 minutes over 1 hour, we can now cancel out hours and hours diagonally. I hope you see that right there. Okay, if you flip this around, then you would actually get hours on the bottom and they would not be able to cancel out. Okay, so you have to make your choice. And so now if we multiply this fraction, we see we get 84 over 60. We get 84 shoppers per 60 minutes. And so if we want to find out how many shoppers per 1 minute, we would divide both 84 and 60 by 60, right? Because then we could divide 60 divided by 60. And so we see on the bottom per 1 minute. And so 84 divided by 60 is 1.4 shoppers per minute. About how many? Doesn't really tell us what to round to, but I think, yeah. Oh, sorry. So it's 1.4 shoppers per minute, but then it's there for 5 minutes. Sorry. So what we have to do is we have to multiply 1.4 times 5. That's my bad. And so we see it's equal to 7 shoppers. Okay. Very nice. And now last problem. The owner of the Good Deal store opens a new store across town. Business is pretty good for good deals. For the new store, the owner estimates that during business hours, an average of 90 shoppers per hour enter the store, and each of them stays an average of 12 minutes. The average number of shoppers in the new store at any time is what % less than the average number of shoppers in the original store at any time? Aha. Okay. So what we want to do here is find out how many shoppers are in the new store, and then use that, compare it to 45 shoppers, and see how much % less it is. So it's a pretty good problem. So we'll do the same thing. 90 shoppers per 1 hour times 60, or sorry, see, I almost messed up. 1 hour per 60 minutes. And see, I'll never mess up because I know that I need my units to cancel out diagonally. Okay. And then we're also going to multiply that times 12 minutes. So we'll do one more. And so actually what's cool is if you see we'll cancel out units diagonally, hours and hours cancels out, minutes and minutes cancels out. And so all we have to do is 90 times 12 divided by 60 to get how many shoppers we have. So 90 times 12 divided by 60 is equal to 18 shoppers. So the question is, how much less is 18? What % less is 18 than 45? So students have a tough time sometimes doing this problem because they know, okay, well, I have to subtract like 45 minus 18, then divide by something. Do I divide by 18 or 45? So how I like to think of it is I like to do the difference for finding out % more, % less. Do the difference divided by the original. What was the original? Right? So if you're going up or you're going down, just think about what was the original value, and that's what you have to divide by. So in our case, we're doing 45 minus 18, that's the difference, over the original, and the original was 45. So if we now do 45 minus 18, it's 27, and we divide that by 45, we see that we get 0.6. So how do we convert 0.6 into some sort of %? What you want to do is to convert from decimals to %, you move the decimal place to the right 2 spaces. So move here and then move here. And since we don't have any, we need a placeholder, we put in a 0. And so that we know that the % decrease was 60%. And so you would bubble in 60. You would do something like boop, 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 and that would be the correct answer. All right. So that's it for section 4. Actually, this is it for practice test 3. We just got through the entire math section. So this is kind of a companion lesson to lesson 6, which was on Tuesday. So if all goes well, I'm going to come back on Tuesday at 7 p.m. Eastern, where we will start practice test 4. All right, so if you're following along, maybe I'll create a playlist that combines all of these lessons together. And please, if you enjoy kind of the style of teaching, but maybe the content is not exactly what you're looking for, you can suggest something new in the comments, and I will take your feedback and try to create maybe more courses that deals with, could be other math topics, maybe even science, biology, and or chemistry. That's something I'm interested in, and I've taught that in the past. So if you have anything else that you're stuck on or you want help with, I'm all ears for user and viewer suggestions. So have a great rest of your week. Enjoy the weekend. Good luck with your SAT studies, and I will see you on Tuesday at 7 p.m.